Question 4. Solve the equation 4 sine squared x minus 10 is equal to 3 for 0 is less than or equal to x less than or equal to 180 degrees. 3 marks. Solution. So the equation is 4 sine squared x minus 10 to be equal to 3. So the first step we can consider here is getting rid of the coefficient by dividing both sides by 4. So you're going to get that sine squared x minus 10 will be equal to 0.75 if I write this fraction as a decimal number. Notice that this is sine x minus 10 multiplied by itself, so we can consider the next step by finding the square root of both sides of the equal sign. So the square root here will lead us to getting sine x minus 10, and then the square root of 0.75 will be 0.866, and therefore x minus 10 will be equal to the sine inverse of 0.866, which will be equal to 60 degrees. And then with the unit circle, we are going to consider that sine will be positive in the first quadrant and also in the second quadrant. And therefore the two values of x minus 10 will be equal to 60 degrees, which is represented by theta in the first quadrant, and then you've got in the second quadrant, which will be 180 minus theta, which is 60 degrees, so the other angle is 120 degrees. And taking into consideration that the range is 0 to 180 degrees, these are the only two angles that will give us an answer in relation to the value of x being in this range. So the first value of x will be x minus 10 to be equal to 60 degrees, and therefore x will be equal to 60 plus 10, so x will be equal to 70 degrees. And then the second value of x will be x minus 10 to be equal to 120 degrees, and therefore x will be equal to 120 plus 10, and therefore the second value of x will be equal to 130 degrees. And these are the two values of x. Question 5. Solve for theta in the equation 3 subtract 3 cos theta to be equal to 2 sine squared theta for 0 degrees is less than or equal to theta less than or equal to 360 degrees. 3 marks. Solution. Let's rewrite the equation here. We are going to have 3 minus 3 cos theta to be equal to 2 sine squared theta. Now that there is sine squared theta here, we can consider the trigonometric identity that sine squared theta plus cos squared theta is equal to 1. So we make sine squared theta the subject. We are going to have sine squared theta to be equal to 1 minus cos squared theta. Back to the equation. So where we are having sine squared theta, we need to substitute with this value here so that we end up having one unknown. So we are going to have 3 to subtract 3 cos theta to be equal to 2 into 1 minus cos squared theta. And when you open the brackets here, you end up having 2 minus 2 cos squared theta to be equal to 3 minus 3 cos theta. And then we put like terms together as we also arrange for the equation. we are going to have, if I take 2 cos squared theta to the other side of the equal sign, I'll have 2 cos squared theta, and then it will meet minus 3 cos theta, and then there's 3 to subtract 2, which will be minus 1 to be equal to 0. Not minus 1 but plus 1, because this is positive 3, which will meet negative 2. In our next step, we are going to let cos theta be equal to x, and therefore in the equation we'll end up having 2x squared minus 3x plus 1 to be equal to 0, and therefore we've got a quadratic equation to solve here. And in this quadratic equation, the product will be equal to 2, and then the sum will be equal to negative 3. And therefore, when you consider the factors there, we are going to have the number 2 and negative 1. When you multiply negative 2 times negative 1, it will give us 2, and yet negative 2 plus negative 1 will be equal to negative 3. And therefore, substituting these coefficients of x in the second term, you're going to end up having 2x squared minus 2x minus 1x plus 1 to be equal to 0. And therefore, we can factor out 2x in the first two terms. We are going to have 2x into x minus 1. And then you can also consider factoring out negative 1 to be equal to 0. That means I've considered the factoring out of the last two terms. And therefore, the two factors will be, we consider what is outside the brackets, which is 2x minus 1, and then we pick one of the brackets, and this will be equal to 0. And then the last step, we consider the values of x. We are going to have 2x minus 1 to be equal to 0, and therefore 2x will be equal to 1. And then when you divide both sides by 2, you get the value of x to be equal to half. Or you can consider x minus 1 to be equal to 0, and therefore x will be equal to 1. So these are the two values of x. We had let cos theta be equal to x. So therefore, we can say here that cos theta will be equal to a half or 1. And then, considering the unit circle, and we know that the cos of theta, we are dealing with positive numbers. So the cosine is positive in the first quadrant and also in the fourth quadrant. But again, the two values of theta will be equal to the cos inverse of a half, or we can talk of the cos inverse of 1. So for the cos inverse of a half, we are going to get 60 degrees, and then for the cos inverse of 1, we are going to get 0 degrees. Therefore, for the values of theta in the range, we are going to consider that theta will be equal to, when theta is 0 in the first quadrant, it will be equal to 0 degrees. And then when theta is 0 in the fourth quadrant, we are going to consider there will be 360 degrees. And then, as far as theta being 60 degrees is concerned, in the first quadrant we are going to have 60 degrees, and then in the fourth quadrant we are going to have 360 degrees to subtract theta, which will be equal to 300 degrees. And these are the four angles that make theta in that range of 0 degrees to 360 degrees. Question 6. Solve the equation 2 cos squared x minus sin x is equal to 1 for negative 180 degrees is less than or equal to x is less than or equal to 180 degrees for max. Solution. Since we are having cos squared x here, we can consider the trigonometric identity that sine squared x plus cos squared x will be equal to 1. And I'm interested in us making cos squared x the subject, so we're going to have cos squared x to be equal to 1 minus sine squared x. And therefore, where there is cos squared x, let us substitute with the solution that we have here. So we're going to have 2 into 1 minus sine squared x, and then minus sine x to be equal to 1. And then when we open the brackets here, we end up having 2 minus 2 sine squared x to meet minus sine x to be equal to 1. We can arrange these terms by putting like terms together now that we know we've got two whole numbers here. So let us assume that we are taking all these terms to the right side of the equal sign. So this term here will become a positive term, 2 sine squared x, and this other term here will also be positive, plus sine x, and then 1 will meet 2, which will become negative. You're going to have 1 minus 2, which is negative 1, and this will be equal to 0. At this point, we can now let sine x be equal to y. We are interested in now solving a quadratic equation here. So we are going to have 2y squared plus y squared and then minus 1 is equal to 0. So we end up having a quadratic equation that 2y squared plus y squared minus 1 is equal to 0. And then we can consider factorization method. So the product here will be 2 times negative 1, which is simply negative 2. And then the sum will be the coefficient of the second term, which is positive 1. And therefore the two factors will be 2 and negative 1. And when you try to confirm, you're going to have 2 multiplied by negative 1, which is negative 2. And then 2 plus negative 1 is the same as 2 minus 1, which is simply 1. So these are the two coefficients that we can use to split the second term. So we're going to have our equation as 2y squared plus 2y, because 2 is positive, and then minus 1y to meet negative 1 there, and then this will be equal to 0. And now that we have the 4 terms, we can consider factoring out the first 2 terms. We are going to have 2y into y plus 1, and then you're going to also have y plus 1 here, and therefore the number that is supposed to be here will be negative 1. And therefore we consider the factors by considering what is outside the bracket, that is 2y minus 1, and then you consider one of the brackets, which is y plus 1, and those are the two factors to be equal to 0. And therefore solving for y, we are going to have 2y minus 1 is equal to 0, and therefore 2y will be equal to 1, and when you divide both sides by 2, we are going to get the value of y to be equal to a half. Or when you consider that y is equal to, when y plus 1 is equal to 0, when you take positive 1 to the other side of the equal sign, you're going to get the value of y to be equal to negative 1. And since we had let sine x to be equal to y, we can comfortably say that sine x will be equal to a half, or it can also be equal to negative 1. Finding the value of x will be equal to the sine inverse of a half, which I can write it as a decimal number as 0.5, or it can be the sine inverse of -1. And therefore x will be equal to the sine inverse of 0.5 will be equal to 30 degrees, and the sine inverse of 1 will be equal to 90 degrees. I've considered two unit circles here, and the first unit circle is in relation to the value of x being equal to 30 degrees, and since the sine inverse was for a number that is positive, we are going to consider that the sine is positive in the first and the second quadrant, which I've considered with the two asterisks. So therefore the value of x will be equal to 30 degrees in the first quadrant, which is theta, and then in the second quadrant you're going to have 180 minus theta, which will be equal to 150 degrees. And those are the two angles as far as x is equal to 30 is concerned. And then when x is equal to 90 degrees, I've considered the second unit circle here. This was for the sine inverse of a number which is negative. So the sine is negative in the third and the fourth quadrant. And therefore in the third quadrant we are going to consider that the value of x will be equal to 180 plus theta. So this will be 180 plus 90, which will take us to 270 degrees. And therefore in the fourth quadrant we will also have 360 minus theta, which is 360 minus 90, which will take us back to 270 degrees. But then 270 degrees is not in the range, because we've been told our range is negative 180 degrees is less than or equal to x is less than or equal to 180 degrees. So we are going to consider that the value that we will pick from there is moving in a clockwise direction from 0 degrees. So we are going to consider that this will be negative 90 degrees, because this is what we can find in the range. And on the graph, this is a point that will appear on the left side of the y-axis. Therefore, the 3 points for the value of x will be negative 90 degrees, and then we've got 30 degrees and 150 degrees. Question 7. Solve the equation for sine x plus 3 tan x is equal to 0 for 0 degrees is less than or equal to x is less than or equal to 360 degrees. 3 marks. Solution. Now that we are having sine x and tan x here, we can consider the trigonometric identity that tan x will be equal to sine x divided by cos x. So this is tan x here. Therefore, where there is tan x in the equation, we are going to substitute that with sine x over cos x. So we are going to have 4 sine x plus 3 into sine x over cos x. This will be equal to 0. And then sine x is common in these two terms, so we're going to factor it out. We're going to have sine x into bracket 4 plus 3 divided by cos x, and this will be equal to 0. We end up having two factors here, and the first one is sine x, which will be equal to 0, and the second one is 4 plus 3 over cos x to be equal to 0. Let's begin by the first factor, where we've said that sine x will be equal to 0. So finding x, it will be equal to the sine inverse of 0. And the sine inverse of 0 is 0. So we're going to have here that x will be equal to 0 degrees. Taking into consideration the unit circle, and we know that the sign of x was not a negative number, we're going to consider that x will be found in the first quadrant and also in the second quadrant. And since x will be equal to 0, the first value will be equal to 0 degrees, and then the second value of x will be 180 minus theta, which will be equal to 180 degrees cos theta is 0, and then the third value of x will be equal to 360 degrees, because we are going to consider the fact that we are making the second revolution where we are back at this point, which is 360 degrees, and the value of theta is 0. Remember also that 360 degrees is within the range. For the second factor, where we are having 4 plus 3 divided by cos x to be equal to 0. So let's make cos x the subject here, and we can decide to multiply each term by cos x, so that we eliminate cos x in the second term here. We are left with 4 cos x plus 3 to be equal to 0. And then we can take the positive number 3 to the right side of the equal sign. We end up having 4 cos x to be equal to negative 3. And then we divide both sides by the coefficient of cos x, which is 4. We end up getting cos x to be equal to negative 3 over 4. X will be equal to the cos inverse of negative 3 over 4, which will be equal to the angle that we are going to get here is 41.41 degrees. In the second unit circle, we are going to consider that the cosine here was negative, and therefore the cosine of an angle will be negative in the second and the third quadrants. And since the value of theta, which is x, is equal to 41.41 degrees, in the second quadrant we are going to have the value of x to be equal to 180 minus 41.41 degrees, and this will lead us to getting 138.59 degrees. And then in the third quadrant we are going to have 180 plus 41.41 degrees, which will end up giving us 221.41 degrees. And therefore we can conclude that having the values for x in the range in ascending order, we can combine them as x to be equal to, we put 0 degrees followed by 138.59 degrees followed by 180 degrees, and then we have 221.41 degrees, and then 360 degrees. And these are the angles in the range that make up the value x.